Hello everyone, my name is Huang Wu, and it's a great pleasure to do this presentation on our paper Joint Attention for Automated Video Editing. In this work, we designed a metric based on cognitive attention that we then used to implement and evaluate 3 automated editing methods for recordings of corporate meetings. This paper is accepted to ACM Interactive Media Experiences 2020 and is co-authored by myself, Trevor Santara, Michael Lees, Rolando Vargas, and Arnold Jala. We're affiliated with North Carolina State University and UC Santa Cruz in the USA and Université Côte d'Azur INRIA in France. So here's the idea. When a number of people are occupying the same space, their attention is drawn to the salient focal points within the space. These can be objects or other people. This attention is expressed, for example, through head and body motions. People will look at what others are looking at. Audio is another indice. When a person or object emits a sound, people will be drawn to and look at the source of the sound. With the development of smart meeting technologies, our capability to record meetings and gatherings is greatly augmented with opportunities towards virtual conferencing, for example. This brings in challenges of digital curation. Taking the example of the AMI database, it features over 100 hours of recordings in smart meeting rooms with 7 cameras, 3 overhead cameras in the center, left and right, and 4 close-up cameras on each participant, plus individual headsets. From all this audiovisual data, how can we create an edit for someone who did not participate in this meeting, showing at each moment the most interesting event? So using the idea of joint attention, we want to create an edit that shows the most salient point in the room at any given time. So to this end, we propose and implement 3 editing techniques based on joint attention: the audio-based edit, rule-based, and long short-term memory neural network-based edits. There's a wide expanse of literature concerning automated editing, so here I will just touch on those that incorporate models of indices of human attention. So in terms of interactive systems, human attention or joint attention has already been used for smart camera switching and for introducing cuts into 360 videos. For example, on social cameras on mobile devices use the camera orientation to determine the focus of the person operating the camera. In 360 videos, the user's head motion is used to introduce cuts towards the next point of interest. In all of these works, though, a big challenge remains, however, in identifying the joint attention from the content and the people within the videos, and not necessarily the person operating the camera or the viewer. Video summarization is another relevant field that uses attentional cues with the goal to extract a storyboard or a sequence of still frames that represent the entire video. So notably, long short-term memory networks have been used because of their ability to model long-term dependencies across a period of time. However, the goal of video summarization is not really to produce an edit from multiple camera streams, but just to select still frames that are representative of the video content. Finally, there's a lot of work on automated editing systems for virtual environments, so notably placing and selecting cameras in the 3D environment that fulfill discourse goals, and also ensure the spatial and temporal continuity of motions and actions, and apply common patterns of editing from filmmaking to achieve story or emotional goals. So 3D camera planning varies greatly from our current challenge in 2 main ways. First of all, the cameras can be positioned anywhere inside a virtual scene, but in smart meeting spaces in real life, they are fixed in a certain position. And second of all, the absolute positions of the cameras, characters, and objects in a virtual environment are known directly and completely accurate, whereas in real life, they can only be estimated. The attentional features we use in our 3 automated editing methods are audio and pose. Audio is pretty straightforward. It's the individual amplitude of the headsets for each participant. For pose, we take inspiration from automatic pose analysis software OpenPose in order to extract the facial landmarks of the participants inside the videos. And using the visibility of the landmarks on the face, the 2 eyes, nose, and 2 ears, we can approximately estimate the orientation of the head and use that, given the configuration of the room, use that to determine where the participant is looking within this environment. So to obtain the ground truth, we asked a human expert to edit 3 videos based on the definition of joint attention. That is, what is the focal point of the room at any given time. So here's an example of the human expert edit.
My opinion, I think it's better under the flip, because whenever you want to the talk, okay, so then you can speak, then you can close it. Because if you put it on the flip, okay, then technical, I don't think it's feasible. Because most of the time you speak, then it will be recognized.
But if you've already got the remote control in your hand and need to open the flip to use the voice, why use the voice? Why not just use your hand? I mean, the whole point of the voice is that if the remote control is sitting there and I'm too lazy to reach over and pick it up.
So the first approach that we implemented is the audio-based edit. It is a naive approach that chooses the camera stream showing the person who has the highest microphone amplitude on their headset. And so there is no smoothing, that is, minimum shot length is 1 second, and contains only close-up shots of the participants. Here's an example of the audio-based edit.
My opinion, I think it's better under the flip, because whenever you want to the talk, okay, so then you can speak, then you can close it. Because if you put it on the flip, okay, then technical, I don't think it's feasible. Because most of the time you speak, then it will be recognized.
But if you've already got the remote control in your hand and need to open the flip to use the voice, why use the voice? Why not just use your hand? I mean, the whole point of the voice is that if the remote control is sitting there and I'm too lazy to reach over and pick it up.
The second method that we implemented is the rule-based edit. Using the extracted pose, we determine the focal point of the room and give a score to each object and participant in the room. Then the camera stream showing the object or participants with the highest score is chosen. There is a smoothing of an average shot of 6 to 7 seconds, and in the rule-based edit there are parameters to adjust, such as the weight on the pacing and the importance of the pose direction. So here's an example of the rule-based edit.
Opinion, I think it's better under the flip, because whenever you want to the talk, okay, so then you can speak, then you can close it. Because if you put it on the flip, okay, then technical, I don't think it's feasible. Because most of the time you speak, then it will be recognized.
But if you've already got the remote control in your hand and need to open the flip to use the voice, why use the voice? Why not just use your hand? I mean, the whole point of the voice is that if the remote control is sitting there and I'm too lazy to reach over and pick it up, I can just use my voice.
The final approach we implemented is a long short-term memory neural network. We take as input both the preceding and current audio and pose data and train the neural network to output the score of the joint attention of each item or participant in the room. And so the intuition for the LSTM is that it can model long-term decisions across multiple frames. There is no smoothing involved here, so the minimum shot length is 1 second, and the neural network was trained on 2 expert edits at any time and tested on 1 and cross-validated 3 times. So here's an example of the LSTM-based edit.
Opinion, I think it's better under the flip, because whenever you want to the talk, okay, so then you can speak, then you can close it. Because if you put it on the flip, okay, then technical, I don't think it's feasible. Because most of the time you speak, then it will be recognized.
But if you've already got the remote control in your hand and need to open the flip to use the voice, why use the voice? Why not just use your hand? I mean, the whole point of the voice is that if the remote control is sitting there and I'm too lazy to reach over and pick it up, I can just use my voice.
Okay, and now I'm supposed to...
I have one question. Will there be anything written on the buttons, like that people know, or they have to learn that from a piece of paper, which button does what?
Yes, it will have, these buttons will have the numbers and all the rest of the buttons will have symbols.
Will have symbols
Yes,
so that,
which
that,
can be easily
that the user
recognized.
really knows,
Yeah.
you know, and
Yes.
doesn't have to
Good
first
point,
learn
because we need the
Yes.
symbols, because we're going into an international
And also-
market. We can't have
yes.
anything that's language
Yeah.
dependent.
But
We evaluated the 3 approaches against the human edit and through user evaluations. Compared to the human edit, the audio edit was more jittery and contained only close-up cameras, while the rule-based edit was less reactive to quick exchanges between the participants. The LSTM edit had more adapted pacing and higher camera variety, and with a pre-trained model could conduct editing in real time. We then conducted a user evaluation comprised of a pre-survey to see if there was any preference between different meetings, and a second part of 9 pairwise comparisons of 2 clips selected from a pool of 36 clips, where there were 3 clips per meeting and 4 editing treatments per clip. And so the users had to choose between any 2 pairs of clips which one was easier to follow and which one was preferred. The participants were not informed that there were different editing treatments between the video pairs. So first, looking at the pre-survey on the meeting preferences, we found that it had no effect later in the pairwise comparisons on whether a video clip was found easier to follow or more preferred. In pairwise comparisons, we found that the human expert edit was still preferred above all other methods, and the rule-based edit was the least preferred of all. And LSTM outperforms audio in pairwise comparisons. Though no 2 clips in the pairwise comparison were the same meeting, we regrouped the preferences for each meeting and found that consistently throughout all meetings, the human expert edit was always the most preferable and most easiest to follow, whereas the rule-based edit was least preferred. And the LSTM-based edit and the audio-based edit closely followed the human preference for human expert edit. There were a number of limitations for this work, notably the training data of expert edits was very limited, and so we were not able to train on multiple kinds of editing styles. And also post-detection for real-time systems is a bottleneck to deploying our approaches in real time that involve post. So in the future work, we would like to evaluate on a larger scale to observe statistical significance between different editing treatments on the perception of users. And we would also like to evaluate whether different editing techniques would be more suitable or less suitable to different contexts. Thank you very much, and please contact us if you have any questions.